Hello, I'm Remington Roberts. I am a senior at Purdue University studying industrial technology, and I graduate in August 2011. Today I will be showing you a project that a group and I completed for a facility design class. We were required to come up with a report demonstrating all the components needed to create a product. The product we chose was bowling pins and bowling balls, and I'm going to go ahead and show you some of the aspects and some of the parts I contributed to this group project. A quick introduction to our project. Our company is S&S Bowling Zone. We are a top manufacturer in bowling pins and bowling balls. The S and S in our name stands for spare and strike, because our company's goal is to bring you the highest quality bowling products, ensuring you play your best game possible. The first step in creating our project was calculating the takt time for our production. To figure this out, first we had to calculate the amount of minutes per day by adding up all of the shift times. So we came up with a 600-minute workday. We then accounted for all of the time needed for lunch breaks, meetings, etc., and subtracted that from the 600 minutes, which gave us 520 minutes. We had an estimated efficiency of production of 85%, so we multiplied our minutes by that, and then we accounted for scrap, and then divided by the total amount of pieces we are making per day, which gave us 0.281 minutes per piece as our takt time. This is the amount of time that needs to be in between each product coming off the end of the line for us to be able to make 1,500 products per day. Using the data from the routing sheets, I was then able to create our line balancing sheets. These sheets have all the calculations needed to figure out how many machines are required for each operation. Using the data from the routing sheets, I was then able to create line balancing sheets. These sheets have all the calculations needed to find out how many machines are required for each operation in order to meet the takt time requirements. We could also come up with an efficiency for our production lines, which we came up to about 89.42%. Another major responsibility I had in this project was coming up with all of the space calculations for the facility. To do this, first I had to come up with all of the space required for the warehouse. We would do this by finding out all of the products and raw materials that we would have in our warehouse. We found the size of all those things and then found the total square feet. Then we could find out how many pallets we would need or shelves, and then how many racks we would need. And using this total square feet, we could find out how much square feet we would need for the total warehouse. We calculated space needed for the office by allocating 200 feet squared per major employee, 100 feet squared for the secretary, a 400 feet squared conference room, and then accounted for aisle space, which gave us 3,800 feet squared. We also found space needed for the maintenance office and tool room. I also had to come up with how much space was needed for the bathrooms, locker, and first aid room by allocating space for each toilet, sink, urinal, door, etc. We also had to come up with space calculations for the break room and cafeteria, which we used a similar method. Then we were able to find the total miscellaneous space we needed for our entire facility, which accounted for the break room, the bathrooms, the locker rooms, the first aid, the offices, and the maintenance department. I had to calculate the space needed for the machines too, so for every machinery we needed to find out how much space the machine took up, how much space the operator would take up, how much space the out bin, in bin, and sometimes how much space the scrap bin would take up. We found this total and then added it to our total space requirement. We found space needed for parking, and then added up everything. With machine and aisle space, warehouse space, receiving and shipping space, and other miscellaneous space, we came up with a total of 24,706.94 square feet. We were able to use this number to then design our facility layout. I designed the entire facility layout for our project. We had to allocate space for the receiving, warehouse, maintenance office, tool room, painting area, molding area, cutting and assembly area, packaging area, shipping, the offices, and the bathrooms and break rooms. Once the facility layout was complete, I was able to use that in Layout IQ to establish the most effective aisle path throughout the facility. We could then calculate the aisle effectiveness of 89.16% using the calculations in Layout IQ. This concludes the presentation. We received the highest grade in the class. We learned a lot about manufacturing processes, and we also had a fun time. Thank you.